information gives you, for example, that this modernizer is actually, well, excluding jQuery here, actually is one of the ones that is taking a little bit more time within itself. And because the total versus the self is like how much did it took to run, and then the total is for how long it was actually used, or percentage-wise. And if I don't, sorry, no, okay. Can you still see it like this? Okay. It's where I have more space. But also very interesting, it's a flame chart, which you can actually, like, let me just narrow down this. I'm using the trackpad just like up and down to scroll. So I'm narrowing the part that I'm actually looking, then I'm spanning to the left, and then I can just like pinpoint a specific sharp edge here. Okay. And this is actually not a big deal if it's a big pile, because what this gives you is actually the stack trace of the calls that were executed on that specific part. So in jQuery 1.9.1, the ready was fired, and then an anonymous function, which was this one. So one of these. Sometimes the prettify doesn't prettify that much. So jQuery was called on the get of set time off. So what you have here, this is not working. Console profiles. Okay. Chrome DevTools are now failing on me because they are not going to the actual moment. Let's see. Yeah. So this profile didn't like it, and it's always selecting the same, which is not the one that I should. Let me choose another event. So load. So if you want to debug, for example, Google Analytics, these were the calls that they made on load. And then you actually got into this case tree. When you're dealing with minified code, sometimes it's a little bit tricky. So you should have always not minified code. But this flame chart gives you a very interesting overview of like where did your CPU profile started using a lot of things and actually used, where is it? So, for example, what it's really interesting here is that if you see a bar that is very long, that means that that specific script took a lot of time to execute. So probably something that you want to work on. Everyone managed to get to this point? Okay. So getting back here to the presentation. No. Also, Another thing that you can use to do pretty much the same, but in a different way, both of them are helpful, is the timeline. So I'm starting recording the timeline. I'll refresh it. I'm going to put a little bit less. And here you have, we are in the events part. So all the events that happen, like I recalculated the style, I received a response, I received 10 pieces of data from main CSS, for example. And you can see like how long did it take, what was the timestamp that he actually started from the beginning of the page, and how long was the package. It also gives you, which is very helpful, the amount of memory that the page is consuming. And all of this that you see here are the document count, how many documents do you actually have in the page, the DOM node count, and the number of event listeners that you have it. The interesting part is that when you are doing profiling of a specific set of JavaScript, if you press that trash bin over there in the bottom, you can actually force a garbage collector call, which can show you like how is your script reacting to the garbage collector. This can be good, for example, to to give you a good overview of memory leaks that you have. For example, when you have like a saw dent pattern, it means that you actually use the memory, and then the garbage collector get it back, etc. When you get like a pattern of stepping up, that potentially can mean that you have some kind of memory leak that you may need to tackle. One of the examples that the Google Chrome tools have a very nice API documentation now. Before it was, not everything is there, but it's much better. And Paul Irish and others are also doing a lot of talks about the dev tools. And this is actually, they have an example where they just put in an array all the references of DOM nodes that they use, so that you can see all the pattern going up and going down of how to use it. You can also see garbage collector events, and there is also window dot performance. Measure. No, not this method. Oh. Okay. So timeline. Another thing that you can use within your script that's very helpful is, so when you're doing now measurements, some people use new date times in the beginning, new date time in the end, you do a subtraction, and you know the number of milliseconds that actually took. But that's not very bulletproof. So you can actually use performance.now that gives you the timestamp that you have with nanosecond resolution, or you can use the combination of console.time, console.timeEnd, and console.timestamp, exemplifying now. So first, what I can show is that I have console.time my timing, and then I do while x so I'm just using x to populate an array, and I do console log, console time, and my timing. Oh yeah. So it took the my timing since it started till it ended. That value is not correct, by the way. And why is that? Because I failed on the middle, and now if I do it again, you'll see that it's much lower. And why did that happen? Because I started timing here, I got a JavaScript error, this didn't occur. Then I did this again, you already were marking it, so he uses the first and then generates this. No, this is wrong. JavaScript, I was pointing at different. So this one failed, that one marked the previous one, and this is actually my timing, which is, so you can just label your timings and use different ones to actually see where the bottlenecks. And you can actually see this and put it on your script, like console.time my timing or console.time end my timing. The other one helpful timestamp is if you're using the timeline and now I call it back. Did you see this yellow line here? That's me marking on the DevTools while a timeline is being stored, where did that specific event happen? So you can actually control this from your script that you're debugging and just like mark it as timestamp, mark it as timestamp, so you can see here with which frequency, for example, that specific event is happening. On this specific case, you can see that there's a third-party script that is actually doing a set timeout on the booking.com website. Another thing that is interesting is, so monitor events, unfortunately, is not available on script, only when you're actually working in the console. You can say, okay, on this object, show me every event of this type that you have. So I want to track all the scroll events on the window. And now I scroll back. And all the on-scroll events that happened were just added. This is not only a useful tool for debugging, but if you want to learn about which kind of events are being triggered, for example, when you type, on key down, on key up, on key press, you can actually see them happening and learn from the console tools. It's not only for debugging. And of course, since you don't want to track them forever, you just unmonitor events and you're done. Questions? Yes? So in performance.now it's pretty much available. Console.time and time end, timestamp. Most probably they are also available. Of course, in Safari most of them are, until they forked to Blink, because actually Google was contributing a lot to the WebKit project, which also has the same dev tools. Now it's not the same case. Opera will get these for free because they just started using Bing on the Opera Next, and Safari also have ones. Since Firefox got some guys from the Firebug team to actually work on their dev tools, and they actually have a big team working on that. They are also doing a lot of impressive stuff. I'm actually starting to go into to dive into the new dev tools. Some of the interactions and the UX, even for a web developer, is not the perfect one, but they are getting really up to state, and it will be I assume that soon you can remove Firebug from any Firefox and just use the tools that they have. For CSS profiling, just to exemplify what you have, you can also just collect the CSS Profiler selector and when you refresh the page, you get back to it, and you have, this doesn't have a chart still, but you can actually also get total time or percentage of how long did the selectors that you are using are taking from the page. Of course, it's not a big deal, usually the CSS performance, but for example, I had one case when I actually had to remove a mouse over effect on an element, which was on the parent, that when I was interacting with the select box, it was freezing. It was Presto, Opera, and Opera Dragonfly also is a very good tool. So actually I had to debug CSS via profiling to understand which were the actual the actual CSS rules that were impacting on the performance of that page. So sometimes you need to debug CSS. I thought that moment would never come until a couple of years ago, but it happened. Because you usually debug CSS for bugs, not for performance hit.
Or crashing a browser if you're using Safari on iOS 7.
Yes, yes, exactly.
That was my time last week.
Exactly. So, paints, reflows. Who are familiar with painting and reflow and why they happen? So, paints and reflows are pretty much what, and in another browsers are paints and layouts, for example in Firefox, because a reflow is a layout event on Firefox. It's just naming, and it's pretty much every time that the browser needs to actually draw a given part, or every time that the browser is actually rearranging all the elements. And that page paint time is like, okay, you want to debug how long it's actually taking to paint your page. So DevTools are cool, and you can actually activate some features that are now available even under General. And for example, so you see that red square there? This is the part that is being painted when I'm interacting with this object. So, for example, I have a mouse over of the element, and I had to paint also the mouse out on the other element. When I'm scrolling, I can see a lot of things happening. Actually, oh, it's not visible here. But if you're doing this in your browser and activate that feature while scrolling, this line here that you can see is actually the scroll bar, which is part of the page in Chrome. So it actually always shows that page when the scroll bar is going up and down. So this shows you like paint rectangles every time that you interact with the page, which is a pretty cool effect. For example, if I do this, I had to repaint all the actual elements within that, because I'm flowing and they are inheriting and getting the thing back. On top of that, if you do animations on your website, you can actually, so force accelerated composition. So it's always showing like how much of the page is actually being drawn at every time, trying to do that on the animation. So, for example, here, every time that I interact with the page, I can see on the top right corner which is the amount of frames per second I can do when something is happening. On this page, this specific part, we don't actually have animations happening. That's why it freezes. Because only when something is happening, that will show you at which frame per second rate you are interacting. And for example, when I'm typing the name of a city here, you can see that we should work a little bit on this one. Although, if you look it up with this one, it actually seems pretty fluid. But if it becomes a bottleneck, maybe we should look into it. On top of that, if you enable continuous page repainting, you can also see, like, this is, so at this moment of time, it took between 1.2 seconds to 14 to actually paint it all. If I start putting this one, it was around 11, then it started going a little bit up. And this threshold will always be, for a given time, how much time it will take to actually paint all the page based on the interactions that are happening. Do I have internet? Yes. So, oh, my internet is so slow. You can see that if you look at the number, every time that the actually image changes, it goes usually up. And if you have some parts of the page that are actually critical, and I can give you an example. So, JavaScript meets Lisbon. And I'm going here. Force, okay. So, observe that here, I'm pretty much at 6 milliseconds. If I go up, I can see like the page time going up and down while the images are coming. And you can also see that actually mouse over an image triggers a little bit too many paints. So when you feel slugginess on the interacting with the web page, this kind of tool is actually something that can show you like where in the actual page is the bottleneck, and then you can dig into the codes to the interaction of that and proceed from there. Getting back to my presentation without this, otherwise it's pretty much useless. So if you want, also, who of you are familiar with the 3D view of the DOM of Firefox tools? Okay. What Chrome has, it's a different thing. Is that when you start with these lovely commands from the console, and you go to Chrome tracing, this is pre-alpha. It's just like me trying to show you what happens when, for example, we refresh. Stop tracing. This takes some time. This is a lot of data. So this is collecting like GPU and CPU data. All this is here. So while it's loading, the thing is, it doesn't give you the DOM nodes tree level. It gives you actually okay, so per element picture. Okay, so Chrome, for optimization purposes, he always renders the full page. What you see at white, it's the viewport. And you can also see how many layers of this page exist. On this case, since we don't have fixed elements, it has none. But if you put several fixed elements on CSS, it will show different layers of interaction on this image. What this allows us to do is actually going to the GPU to see where are performance bottlenecks, which is like going outside of network tools and go to a much more deep level. And you can see how this can be super valuable if you're doing stuff with Canvas, for example. And going back. Almost done. Also in the tools, if you want to see the network panel, which it's much more common to use than some of the others that I showed. Just a small detail of information. It gives you all the things about connect time, non-connect time. If it comes from cache, which type of HTTP connection happened, status code, etc. And there's always two blue lines. This is DOM content load, and this is DOM load. And this can be helpful, for example, to see if any given script is actually going quicker triggering than you wanted. For example, you want something to trigger on onload. If you see that it's actually triggering on already, you're debugging bad. For example, when you have a Facebook stuff or Google, you may also need to look into this to actually make sure that they are triggered in a moment of time that don't affect your page load time. And of course, for those who don't know, if you want to do this network panel view in any browser from any location. You can use webpagetest.org, which is open source. It's maintained, not open source, but it's open. No, you can actually set up instances of web page test locally. I've heard of companies that did that. Last topic regarding this. Front-end Spof, which is all of these things about measurement is trying to find bottlenecks. So there are anything that you can load from a custom font or your JavaScript file or any other third-party widget. What you don't want that it makes a blank page on your screen. I can show you guys an example of so I have a small plugin that I use called, I'm using this, wait. Okay. Here we go. So the page loads pretty fast, right? And now I'm going to load it again. It's the same connection. It was like 3 seconds ago. It's taking ages. This plugin is called Spof Resource Blocking. And this is also available on web page test. What it does is that select URLs that are known for being bottlenecks, and it sends it to a black hole. This is like blackhole.webpagetest.org. So what happens is that there is a font face on this website connected to Google Fonts, and Google Fonts is not responding. So I can even go to now the web tools. Well, no, because I didn't have it open. So actually, if you look, I'm just exemplifying. So restarting. So JavaScript is downloaded, CSS is downloaded, and then everything is pending. Why is everything pending? Because this web font that is in your CSS, that as it should is in the head, is actually preventing the rest of the page from being rendered. And until it fails, your page stays blank. So this is a good thing, for example, to see if Twitter, Facebook, Google Plus buttons that you may have on your website are actually preventing some parts of the website from being displayed if they are not working properly. And I was here. And pretty much the approach that we have at Booking is like log everything you can. It's very easy to make like beautiful charts, just throw information, use Reddit, use Hadoop, things that you can use like freely, and just get information out of it. If you don't know it's happening, you'll never fix it. And usually, based on our experiences, usually people don't come out to you because there's competitors. If you're working for a niche that you're the only website or service that everyone uses, that's fine. But for our business, there's a lot of competition out there. So if it doesn't work, they go other way. They will not complain. And that's for me. Okay. As